last file of this one. So ready? Okay. As the opponent pick a problem to challenge the voter, I have 1 minute. Problem number 6, non-contact resistance.
Isn't problem number 6 rejected by other?
It is the same PF and lost it cannot.
I think they rejected number 4, number 6, and number 7.
We didn't reject number 6.
No.
我们 reject 的题目是哪几个上面？
We reject. Sorry.
Okay, the problem is being rejected, so you have another minute to pick another one.
You want to challenge problem number 10, magnetic gear.
Problem number 10, magnetic gear. Accept, or problem being accept. So further you have finally prepare your presentation. Also, so you can please write down the name of your presenter on the slide. Okay, reporter, please.
Okay, so good afternoon, juries. Today, I'm the reporter of Team Lagrangers. Today, I'm going to report about problem number 10, magnetic gear. So this is our experimental outline. Please wait a second. So there will be the problem statement, and then the observation video, discussion of perimeters, and then our experiment, and then we will conduct our theory, and then there will be our conclusion. Sorry, please wait a second. Okay, so this is the problem statement. We have to take several identical fidget spinners and attach neodymium magnets to their ends. So if we place them side by side on a plane and rotate one of them, the remaining one starts to rotate only due to the magnetic field. So we have to investigate and explain the phenomenon. So this is our observation video. Oh, wait. What? Sorry. Okay, so this is our observation video. Okay, so we can see the passive spinner also spins when the active spinner spins. Okay, so this is our discussion of perimeters. We did 4 experiments. There are 4 different independent variables. The first one is the number of blades. So we will have fidget spinners that are 3-bladed and fidget spinners that are 4-bladed. And then the second experiment, we have we are discussing the distance between the center of two fidget spinners. And then the third is the magnetic strength. The fourth is the number of gears, which is the number of fidget spinners. And then the dependent variable, which is the thing that we are going to measure, is the angular velocity of the passive spinner. So this is our experimental method. So we have a motor over here, and then this is a plane. We have an active spinner over here, and then so when it spins, the passive spinner also spins. So we use we take videos to record the angular velocity. So these are our preparatory work. So before we conducting the following experiment, it is necessary to confirm the effect of the numbers of magnets on the magnitude of the magnetic force and the effect of distance on the magnetic force. So this is what our experiment looked like. And this is the result. And then the chart shows the different strength of magnetic force due to the effect of the number of magnets. And so the second thing, we have to measure the impact of different magnets on moment of inertia. So these are some definitions that we made. And okay, so we can take a look. This is the formula that we applied into our theory. And this is the result shown over here. And this is also another theory shown over here, and then you can clearly see this one is the inertia of movement that we are trying to get, and then so you can see the numbers over there. Okay, so let's go to the first experiment. We're going to discuss about the number of blades and what angular velocity would it bring. Some of our experiment setup, we have to have magnets, and then 15 magnets, and 3D printed spinners with 2 3-bladed ones and 2 4-bladed ones, and then a motor and a camera. Okay. So this is our experimental setup, just like I mentioned before, and this is the actual picture of it. So this is our observation video when we discussed 2 3-bladed fidget spinners. Okay, so this is the experimental result, and then so the number of blades of active spinners is 3, just like the video shown, and which angular velocity is 3.372 RPS. And then you can see over here, so this chart basically shows that the active spinner is always the same, always 3-bladed, but then this one is the different blades of passive spinners, so you can see a significant difference between them. And then, so this is our experimental result. And then the average of angular velocity is 3.369. And then theoretically, the frequency of the angular velocity oscillation is 3.369 times 3 equals 10.107. And then why we times it 3 over here is because we separated into 3 when we discuss it, so then we have to times 3 when we put back to it. And then so we did a Fourier transfer to see the peak of the frequency, and then we can see it's 10.202. And this is also the experimental result of the 3-bladed one and the 4-bladed one. And this is our observation video. And so you can still see this time the active spinner is 4-bladed, and then you can see the passive spinner is also 3-bladed and 4-bladed, and you can observe the angular velocity difference between them. So also our experimental results, we are using the Fourier transfer to see the peak of its frequency, and then it's shown over there. And then this one is the 4 versus 4-bladed one. So our second experiment, we are going to discuss about the distance between the center of two fidget spinners, and then the effect that it has on the angular velocity. So we also have magnets, also have 3D printed fidget spinners, motors, and cameras. But this time we only choose the 3-bladed ones. And then so this one is also our experimental setup. It doesn't have a big change. And then so this is the experimental result. The active spinner's angular velocity is 3.372 RPS. And then why didn't we do 8 cm is because the distance between two fidget spinners are bigger than 8 cm. And then why didn't we use 11 cm is because if we put them 11 cm apart from each other, they cannot get the magnetic strength to each other. Okay, so this is also our experimental result. When the distance is 9 cm, we also did the Fourier transfer to see the peak of the chart. And this is the 10 centimeters one. Okay, our third experiment, we are discussing the magnetic strength versus angular velocity. Also, we have magnets, but we have more magnets. This time we have 18 because this one we are mainly discussing about magnetic force, which we are going to change by adding magnets to the fidget spinner. And then also fidget spinners, motor, and camera, like usual. Experimental setup as usual. And then this is our experimental result. And then we can see like the 1 magnet, 2 magnet, and 3 magnet ones are almost the same. This is our Fourier transfer for the 1 magnet one, 1 magnet experiment. The experimental result for the 2 magnet one, the experimental result for the 3 magnet one. Okay, so we are now going to the 4th experiment, which we are going to change the number of gears. We used to have only 2 gears in the previous experiments. Like in experiment 1, 2, 3, we only had 3 gears, so now we're changing it. So observation video. 3 fidget spinners one. And then this one is we used Python as these to make an animation and simulation to to show how these 2 fidget spinners will interact. And then also the same, we have more fidget spinners, and then this, and then the result also. And we can see the simulation. We put the previous data we get from experiment 1 to 3, and then we can get this simulation by computer, and then we can see that it quite matches with our experiment result. This is our theory. So transfer of angular velocity. The active spinner, so being powered by a motor, it exhibits a significant and controlled angular velocity. And also magnetic interaction. So they transmit angular velocity from the active one to the passive one. Also, magnetic interaction. Magnets are used to transmit the angular velocity from the active. Yeah, this is just like what I mentioned before, but there is a chart to show that there is an oscillation. And conclusion, the angular velocity of the passive gear is related to the gear ratio. So we have this formula. The angular velocity and the passive angular velocity, there is a relation that looks like this. And then our our experimental results, previous results also match with this. So the angular velocity of the passive spinner oscillates over time, and the frequency of this oscillation is related to the number of blades. And then so you can also get this formula. The definition is below. And then conclusions, we can get this nearly identical experiment and simulation results, which proves our theory and results are correct. And because our theory are correct, we can use this data to put it into Python, and then we have a stimulated video for the 4-geared one. And then this is our conclusion. The repulsive force applied by the magnets on the active spinner is the main reason to rotate the passive spinner. Okay, thank you.
Okay, some short question from the
First of all, can you please turn page 5?
Page 5? Okay. Can you just turn to page 5? Where's page 5? Okay, page 5. Okay.
So,
Oh, sorry.
for the first point, operator developer variable, you're only changing, you only have 3, for first point, you only have 3 numbers and 4 numbers of place, right?
Yes.
So that you only design it here.
Can you
You only
repeat?
did 3 and 4 placements.
Yes.
Then can you please turn to page 8? Sorry, page 9.
Page 9.
Well, the part for the series part, like, before you discuss about your experimental results.
Oh, the page, which page?
About page 9, yeah.
Page 9, yeah, okay.
So, what is the meaning of the symbols on the coordinates?
Okay, so we made charts for so look at this, we have this L and then F. So I can see that F is the force and then L is the distance and then I make it to like natural log.
Go to the previous page.
Previous page.
Is this an experimental setup?
Yes. No, this is just like a preface for our experiment. Yes,
Okay,
this is.
okay, I see. Can you please turn page 19? What is the vertical axis of your graph?
Oh. No. It's just the rate. It doesn't have a unit or something because it's Fourier transfer. Yeah, you transfer it into. So I have all the raw data and then.
I'm sorry, time.
Oh, okay, sorry.
Only 3 minutes to prepare. Okay, opponent please.
Hello, this is an opponent from Team PF1. My name is Xu, and I'm going to be the opponent of problem 10 magnetic field. And this is a problem statement. So they are going to focus on several identical prisms and side by side on a plane and rotate one of them. And due to the magnetic field. And this is the overall summary of the reporter. So for the theory, we are using the transfer of the magnetic force into the angular velocity and talking about the magnetic interactions. And for the setup, they use a motor to rotate the active spinner and a camera to observe the motion, and spinners and magnet. And for the parameters they are going to discuss is the number of plates, the distance between the center of the two spinners, the magnetic strength, and the number of gears. And the analysis, the dependent variable is the angular velocity of the passive spinner. And these are the advantages. They have great coherence and organization about their theory and experiment. And their experiment setup is clear and simple. And they have a lot of experiment data. And our suggestions is maybe they need clear expression of how they get the equations in the theory. And we still are not very clear about the y-axis of the graph. What does it mean? What rate is it? And also, at first they wasted a little bit of time, but I think that's okay. And these are the main points of discussion. So first, I think that I need to know about the method of calculating the results of the equations of the theory. And second, I want to talk about the vertical axis, and also not stated on this presentation. I didn't have time to do it. It's about the critical values of experiment 2. Yes, and this is the end of my overall summary report. So, okay, so first of all, turn to page 19, please.
19.
Yeah. Page 19. Yeah, so I still want to know what kind of rate. Yeah, I know it's a rate because I know there's no units on the y-axis because it's a rate, but what rate is it? Can you
Okay, I can explain it. So we did our experiment, and then we, by our camera, we can see the angular velocity, right?
Yes.
And then because of our angular velocity, and then we have some theory, and then so we can use our theory to get our frequency, and then when we get our frequency, we also have like the angular velocity, and then the time, the chart. I didn't show it over here, but then I have the chart.
Like simply draw it on the blackboard because I need the like so. What is it like for?
So I have an experiment, and then I can get my angular velocity, and then angular velocity, and then by my theory, I can get my frequency, and then.
Alright, wait. So now I want to ask, the angular velocity is the result of your experiment, right?
Yes, yes.
And then the frequency is what you predict from your theory.
Yes.
Then do they fit to each other?
Yes. So that is why we use that is why we change it to that chart. So then now we have this, and then from the experiment we can also make a chart of omega and time.
Yes.
And then
how does it look like? Like what will it look like? The graph of omega over time.
I cannot draw the chart. Oh no, the chart is actually over here, the omega and t.
So it's according to your theory, right?
This is not actually theory. This is our result.
In your theory page. Well, then I suggest you, it's like this, there's the 47, page 47. Yeah, so you said this graph is the result of your experiment, right?
Yes.
Yeah, so I suggest that if you want to put it in a theory page, you can do a better way is you can draw another graph of the prediction of your theory.
Okay.
And then relate each other and say that they are identical.
Okay.
Okay, so maybe that's the point. Okay, that's okay. Then
Okay.
I can hold it. And can you now turn to page 5, please?
5.
Oh, sorry. Actually, you can just turn to the first experiment.
First experiment.
And next page.
Theory.
Next page.
Theory.
Yeah, this one. Okay, so you only did 3 base and 4 base. Then I want to know if that, like, you only did these 2 numbers. Then why don't you do 5 base, 6 base, 7 base, or even only 2 base? Like, is there a meaning for it, or?
If it's 5 plates or 6 plates, and then the distance between each plate will be too small, and then so the effect won't be that. It won't be that it won't show as good an effect as this one. The phenomenon can be recreated better when I only use 3 plates and 4 plates.
Okay, I see. Then is there a trend for your results
For this chart?
Because you only have 2, 1 for 3 base and 1 for 4 base, right?
Yes.
And from these 2, can you predict the sort of how does it relate to each other? Or the-
I have a result from that matches with this one, which is over here. So this is the formula that we get from our from our experiment result. We can see the active spinner's angular velocity is nearly equals to the passive fidget spinner's angular velocity times the blade passive spinner's blade divided by active spinner's blade.
Then from for this formula, can you calculate from only theoretical models? The process of getting this formula only by using theoretical models.
So you mean do I have the
Not from your experiment to get this formula. Can you get this formula from only theoretical models or theoretical?
I guess we didn't do that. We didn't predict it from the theory, but then we only get that as a conclusion. Like when we observe our results, we get that
Okay,
formula.
so what I think is the formula might affect, the accuracy of your experiment result might affect how the formula will work. Maybe there's another coefficient. And
Yes.
you can consider.
Okay, I agree.
Yeah, so maybe you can do more experimental data, or maybe you can try to use some theory models to calculate the formula and try to prove it.
Okay.
Okay, then can you please turn to page any page that you have your observation video.
Any page that I have observation video. This one. Yeah, this one is fine.
I need the ones for only 2 fidget
Oh,
spinners.
2 fidget spinners.
Yeah, thank you. Okay, so from this video, you can which one is the active one and which one is the passive one?
I forgot to explain. There is a motor over here. So it's my fault. I didn't explain. The active spinner is the one on the right.
All right, so and can you play the video?
Play the video.
So you can see that the passive spinner is rotating clockwise, right?
Yeah.
And the active one is rotating counterclockwise.
This is.
Yeah, so have you considered any sort of different angular velocities for active fidget spinner that may affect the direction of the rotation of the passive one?
You mean by changing the angular velocity of my fidget spinner, the direction might change?
Well, do you think it will change?
I think because the passive spinner it rotates because of the repulsive force, and then I think when the angular velocity is like, well, we actually didn't do the analysis or more experiments for it, so I cannot tell you like
Then can
why.
you predict it from your theory, or you don't have any models or equations that you can get from your theory?
Oh, so this is gear over here, so its direction stays the same.
Well, I mean the passive one. You don't have a gear on the passive one, right?
Yeah.
Yeah, so the passive one can be freely rotated. So it can be in another direction, right? Then what do you think what factors might affect the direction of rotation for the passive one?
Of course, the spinning direction, and then I also think that angular velocity might also be a factor for it. If you like, when you spin it faster, the passive spinner has like it has less time to react to the force to it, and then also the faster it spins, the more complicated the force is applied to the passive spinner. So that is why I cannot tell you now because I don't know also. Like I didn't find the boundary
Can you
for it.
sort of predict it, like for faster active fidget spinner rotations? What do you think that the direction of the passive one will change?
I think we don't have to look at the direction. We're just
Yeah, okay, I see. They're going to please take a experiment 3.
okay.
So for experiment 3, the independent variable is the number of magnets, right?
Yes.
So you stick the So is it the number of magnets on one blade or the total number of magnets?
You mean?
Like
Can you rephrase it?
You said you changed the number of magnets, and I want to ask if you're changing, like, how do you define the number of magnets? Is on the number of magnets on one blade or the total number of magnets?
So we like 3 over here. One for the one magnet one is like 1 each on each fidget.
So it's a number on each blade, right?
Blade, yeah, on each blade. That's why we need 18, like 3 times 3
Oh,
times
okay, I
3.
see that. So, do you think that you are changing the mass of the magnets also by changing the number?
Yes.
Yeah, how will the change of mass affect the result?
I didn't see like really big
Yeah, but from the chart, you can
effect.
see that you are changing the mass and the number of magnets for the
Yes.
magnetic force at the same
Yes.
time. Now, you're changing 2 variables at the same time.
If you want to say it like that, it
Yeah,
is. So we
I
can
think
see the
it should be more accurate. You have to
Okay.
try to, so that, I think
So,
that might affect the result
but-
because.
Do you think that if I want to make the mass the same, I need to make 3 different fidget spinners to like?
Can stop the time.
Thank you,
Thank you.
So, Roland can summarize the discussion.
Okay, and this is a conclusion of the opponent. So first we discussed about the y-axis of the graph, and because we need a more clarification on it, and they explain very clearly about what rate it is. And second, we talk about the data of the first experiment, which is changing the number of blades. And we think that they should have a more accurate and more experimental data to get the formula they get from the theory. And then we Another main point we talk about is that for experiment 3, you are changing the element's magnetic force and the mass at the same time. And I guess it will affect the motion. And for experiments, you can change 2 variables at the same time. And this is the overall conclusion of our discussion. Thank you.
Thank you. The question from the viewer.
I would like to ask the reporter first. First of all, are you using a digital camera to capture the video or use a phone camera?
Oh no, I use slow motion, like real camera, not the ones on the phone.
Are you using a slow mode or original?
What do you mean?
The video velocity.
What?
Is it slow mode? Is it not slow mode or original?
So, of course we know, if we want to analyze how fast it spins, I have to slow it down. And then after I slow it down, I know how many times that I slowed it down, and then I can count the laps, and then I get the angular velocity, like how fast it spins, and then I can time it back and get my real angular velocity.
Are you using any check software to analyze the angular velocity?
Yes, we use a tracker. So you can see there are stickers over here, and then there is a blue dot that we use to mark, and then so we can put it into something like a tracker and then make it calculate or measure it for us.
Have you calculated how many times you reduced on slow mode?
Yeah. The video is 16 times slower than reality. So then I can calculate it, and then I know when I time it, like times it 16 times, and then I get the real angular velocity.
And I would like to ask, as an opponent, are you you guys are making this experiment? In the phenomenon, have you seen the gear will oscillation in the experiment?
You're asking me?
Who are you
the
asking?
opponents?
Sorry.
I'm asking a reporter.
Okay, can you repeat your question again? I thought you were asking him.
Your gear may be able to oscillation in the experiment or not?
What kind of oscillation? You mean when
The-
it spins or?
No, the phenomenon.
No, we don't. Actually, we are not focusing on the vertical oscillation on it, but we are focusing on the oscillation on the horizontal axis. Yes.
I'm sorry, that's a good time.
Thank you.
Alright, first of all, we are going to talk about how their pros and cons. And the advantage is they do lots of experiments on their PowerPoint, and they have to do the analysis and experiment completely, and also have things that's a variable on it. And in this presentation, we are going to the important focus on magnetic field and frequency. And we are going to suggest them is their final of the experiment have to connect all of the data points on their data that we can know clearly on their data. Okay, and we are going to discuss the experiment and theory. Their experiment have to 4 experiments. It's about changing different variables, such as numbers of minutes and gears, and also blades. And then theory is going to talk about the magnetic field, how the magnetic field to influence the experiment. And my first question is about they are using a camera, and have they used the slow mode to record the experiment or not? And they use it. Also, if they didn't calculate the times back to the data, the angular velocity will be wrong. But they have to. And after that, they use the chamber to analyze it and to analyze the exactly data on it, and also have combined what I say just now is to calculate back the time on it. But they didn't check what the y-axis will do on the experiment in another site. Right, and this is my report.
Okay, thank you. So, concluding remark on the report.
Okay, so this is, I'm the reporter. This is my concluding remarks. So first of all, I liked how the opponent gave me some advices, and also about my time management. I should prepare my device earlier. And then so about the summary of my report, I talked about the relation of gear and angular velocity, and then I used the fidget spinner to represent the gear. And then I also use simulations to predict the experimental result, and it quite matches, so that proves my theory is correct. And then I also use Fourier analysis to find the main frequency of oscillation, which is every chart I have shown over there. And then I also have used tracker to calculate angular velocity. Yes, auto track with the blue mark. And then I take account of several variables to make sure the gear's characteristics. Opponent summary. So he asked about the analysis of angular velocity. I should change and use more different angular velocities. Also the number of blades. And because I only have the 3-bladed one and the 4-bladed one, he also advised to talk, maybe if I do more experiments, I can find a coefficient of formula. And then he also asked about if the angular velocity would change the way of rotation. And then he asked about the mass of the spinner. And then the discussion summary. So y-axis is the normalization by Fourier analysis. So I did Fourier analysis, and then I did normalization. So that is why the y-axis is between 0 and 1. And then the direction of gear turning could not be known while speed is too fast. So according to the question, point is angular velocity oscillation frequency. Okay, thank you. This is my report.
Okay, thank you. Question from the Joe.
Another question. For reporter, you showed a lot of Fourier spectrum.
Good.
So you just pick the main peak as your signal, but the Fourier spectrum are very, very noisy. Why? What is the reason for that? Is a question for you and for opponent and the reviewer.
I
Do you have any
think-
comments on this?
I think because there are a lot of noise like under the graph, right? So
So
I think
are
there.
they Gaussian white noise or some other noise?
I think there might be human errors or
Okay.
yes that's just human error in our Fourier analysis.
Your idea? Do you have any comments on this?
I think that, well, I didn't really know why the peak, well, why is there a peak in there, because it didn't really actually explain in the theory, but I believe that the noisiness of the below of the graph is, yeah, I think that it might be human errors too.
I think it may be able to come about from human because it may be able to touch the table or the wine may be able to influence that. So I think the natural and human will be also influence the data.
Yeah, and there are also some sort of, maybe I also think that there are also some energy dissipations due to some other forces that we might not consider about.
I have a question for three of you.
Yes.
Do you know the reason why the rotation direction for the active spinner would be different from the passive spinner?
Because when it turns, it gives an like repel force. So then when it comes over here, it gives a force to repel it, and then so the rotating direction is not the same. And then also because we are using a gear under it, so if there is difference between the gears, then when it rotates, it will be like in different direction. Yes.
I think that it might depend on the placement of the North Pole and South Pole on both, or maybe three of the fidget spinners. I think that the direction of the magnetic force will affect the direction of the rotation. And also the angular velocity, when we, like just as the report said, we didn't have a method of analyzing the faster speed of angular velocity.
I think because the magnetic lines of the force will when you rotate it, each magnetic line of the force will be changed on the rotation. So I think it will come about from the magnetic lines of force change.
Okay, thank you.
So, I have one short question for the reporter. Can you show your conclusion?
Oh.
My question is, so you get the last formula for the frequency of omega of the passive and active engagement.
Yeah.
So, is your prediction or your conclude from your
You mean which one? This one?
The prediction from
This.
yes, this one. Okay, the last one is your prediction or your conclusion from your experiment.
No, this one. because I have the angular velocity for the active and the passive spinner. So I can get the, so I have these two and now.
Your guess? Do you? How
Yes,
many
this is-
experiments support this? Do you have any data?
Yes,
Experiments support this?
the one, wait, I guess it's experiment 1, if I didn't remember it wrong. Yes, this, if you put these two into it, I get that
This is the
formula.
only data you have.
No,
Because
this one and
the
then.
2 brand and the 10 grade. You have this one?
No, and then, yes, I only have the 3 bladed one, and then the 4 bladed one. But then I have 4, actually I have 4 experiments set up. That's 3 and 3, 3 and 4, and then 4 and 3, 4 and 4. So that's like 4 different combinations.
Okay.
Yes, and then I can get that formula. Okay.
Okay, I guess two questions for opponents of all review. You believe that? The last formula?
Well, yeah, of course they can say that if they put the number inside the formula, like it fits the formula. But I think that because they only have 4 kinds of data, I think that it's not enough for doing it.
Same as the opponent. I think they have no enough the combination to
We'll agree and so you
disagree.
I think it's a formula that we get.
you have your chance. Okay.
Okay, thank you.
Okay. So any other question? So that's okay. Okay, let's go to the scoring section. Thanks for the reporter first. Which your 6, 7, 8, 8, 8. Then opponent is 7, 7, 7, 7, 8. Then reviewer. Is 5, 4, 4, 6, 6. Okay. Thank you. So anyone want to make some comment? Okay. Okay, let's close this round. Okay, thank you everyone.